So in this problem, I'm looking for the graph of log x, and I want to use left end Riemann sum, where n is 2, to approximate value of that. So the conceptual idea is I plot the graph of the log function, 3, 4. So this is a graph of my log function, and I'm having 3 through 4, and then I have my 3.5 here in the middle because I want to split it into 2 intervals. I'm using left end Riemann sum, so I'm picking my heights on the left end, So I get my 2 intervals here. The first one looks like this, the second one looks like that, so I get my 2 rectangular shape. So all I need to know is what's the area. Well, each one has a base, which is a half of the interval, which is a half of the size 1 interval. So each one has a base of 1/2. And then I might multiply their heights. I'm using left end Riemann sum. So this point has log 3. This point have log 3.5 as a height. So I can find this relatively easily. Well, if I'm using right end Riemann sum, it should be focusing on the same graph, except my region is supposed to be a rectangular based on the heights of the right side of my region. So it's something looks like that and this. So the right end of this interval is 3.5. The right end of this interval is 4. Therefore, the corresponding function value is ln of 3.5 and ln of 4. They again have the same side of the base, which is half. Therefore, this is what I'm going to end up with. You need to carry out the calculation. So which area is an overestimate? Which one is an underestimate? Well, this is a monotonically increasing function. So if I look for the left end, I always underestimate. Therefore, I'm going to be underestimate when I use left end Riemann sum. This is increasing function. If I always choose the right side of my interval, I'm picking the highest point of this interval to represent the whole thing. Therefore, I always overestimate. So I'm going to say my right end Riemann sum is always going to overestimate my